All right, what we got is right in front of you. You should have two pieces of paper. You have a big old blank quadrilateral hierarchy, right, that we're going to fill out. If you remember that I told you that literally is the last question, the last page of the test. So here is the fourth page of the test. There is absolutely no way that we could fill this all out today. I mean, we could. It would just melt your brains of how much information that I just shoved down your throat. So we're going to do a little part of it. And then there's another worksheet about kites and trapezoids, so that's kind of what the message is today. But here's what I want you to do with this hierarchy that's in front of you. Please put the word corrects right here, because you're going to have quite a bit of these hierarchies handed your way to where I ask you to fill them out. This is the one where you know that this has got all the right answers on it, because we're going to fill this one out together. Does that make sense? All right, so this is the correct one. And don't let it overwhelm you. If you truly study this stuff, it really isn't that big. It starts at the top. I want to know the definition of a quadrilateral. We know the definition of a quadrilateral. What is the definition of a quadrilateral? Four-sided polygon is correct. So you can pause the video if you need to, but I'm going to go really quick. Oh, man. On your homework, you know, it asks a good question. You know, a lot of people, I'll talk about homework here in a second, though, realize, remember convex means like it can like, it doesn't dent in, so doesn't non-convex things like have a dent in it? Who was the answer besides quadrilateral of which one of the quadrilaterals could be non-convex? Who was the only other guy besides the quadrilateral? The kite. And you know why? The kite is the oddball in the family. That's what we talked about last time. What doesn't the kite have that everybody else in the family is going to have? Parallel lines. It is impossible to draw two guys parallel to each other, right, to have a set of parallel lines and put a dent in your guy and still have four sides. Would you believe that that has five sides now in that case? So the kite was the weirdo. Speaking of kite, let's go get his definition. He's the hardest one. See if you can tell your neighbor real quick what that definition is. Like that? Would you believe that a kite has two distinct pair of consecutive sides equal? You can abbreviate how I abbreviate it. If you can't fit it all on that line, that's okay. You know, I get that. You know, just try to squeeze it all in there. But it's got two distinct pair of consecutive sides equal. Then they want to know if a kite has any symmetry lines. So what do you think about, like, if I was to do this? Does this look like it would be a symmetry line? Is everything above that blue line like a mirror image of everything below it? Yeah, probably not. What if I did it like this? Would you think that everything on the left side of that guy is a mirror image of everything on the right side? That is going to happen. So when it comes to these symmetry lines, here's what you got to tell me on the test. First, you got to tell me how many there are. Answer, one. There's one symmetry line, right? Then you have to tell me where he is exactly in the words that I give it. This one symmetry line for a kite is through the ends. So you got to say, yo, I got one symmetry line, and it's through the ends. I will tell you what the ends are here in a second. So where are the ends of the kite? I have this kite drawn off to the side. You don't need to have it. It's just kind of like a little visual example. The ends are where the two sides that are the same touch each other at, where two sides the same touch. So give me an end of kite A, B, C, D. Who's one of the ends? B. Don't two sides the same touch each other there. And who's the other end then? D. And if I was to connect those with a line that goes through that, would you believe that that is the symmetry line in that case? The symmetry line goes through the ends. Cool. I'm going to draw in this diagonal over here also. So there's like one of the diagonals. Let me change colors. What would you think fanciness-wise it looks like with those diagonals? Do they look like they are perpendicular? What do you think? If you was to take a guess, do they intersect at a 90? Yep, that's all that's going on. That's the fancy part about them, that they are perpendicular. If you want, you can put that symbol. Do you remember what the symbol looks like for perpendicular? What's that look like? Upside down capital T. So I don't care if you write out the word perpendicular, if you just put that symbol. But those dudes right there totally intersect at a 90. Out of the other fancy things, I just want to talk about it, even though it's very strange to us. They do not bisect each other. It is totally true that this red diagonal does cut the green one into two equal pieces. That will happen. But my question is, does it work the other way around? Does the green one cut the red one into two equal pieces? So when I say bisect each other, it has to be a two-way street. The red one cuts the green one in half, and the green one cuts the red one in half. That's not happening, right? And they're definitely not the same length. So the only thing that's fancy about them is they are worksheet and kind of like do some problems about kites to get a little more in depth with them. So on number 1, they say use your geometer to draw kite John with ends O and N. Mark the kite by definition and draw in any symmetry lines. Remember, there's not a kite on your geometer, so you're just going to have to like take your straight edge and do your best job of making one. It's not going to be perfect, you know, but give it a shot. So since O and N are supposed to be the ends, I'll label them. And then that means I got to go around the clock and spell the word John also, so you have to watch that. And to mark it by definition, which we are, it's not that you don't know what that is, we're just not doing it. You know, it's like you mark a kite by its definition. They said draw in any symmetry lines. Sweet. This is brand spanking new for you. Grab the hierarchy. That's the whole reason why this is on the test. I would do that first. When I hand you the test on test day, there's 4 pages, that's the 4th page, I would do that one first, you know, because when you put all that stuff in there, if it's correct, it's going to answer every other question on the test, because they want to know where the symmetry lines are. Cool, look it up. Does a kite have any symmetry lines? Yes, where at? Through the, so we'll draw that dude in. And because he's a line, we do need to like put arrows. So it's not like a diagonal, you know, it's going to go through the kite and put some arrowheads on him. All right, put some arrowheads on him. So they said draw in any symmetry lines. So that's nice. So that was John. Number 2, they ask you to draw the kite Cena. Mark all that stuff, what it says. Work with the neighbor. Why don't you pause the video and get that done real quick. There's mine. Don't forget you got to mark him by the definition. Now, it doesn't matter where you put the single ticks and the double ticks, but you got to have a set of singles, got to have a set of doubles. They say draw in the diagonals and then mark if there's anything fancy about them. Well, it's still very new to us, right? So I'm going to draw in both diagonals. There's a different color than red. There's a green one and a blue one here. According to your hierarchy, where we have diagonals as a blank, what was fancy about them, if anything? They are perpendicular, so shouldn't we put that right angle box? Are you okay with that? And you just got to put it once on that situation. But the diagonals of a kite are perpendicular. Cool. All right, those are pretty basic. Then they say this. Ooh, here's my question. Look at that shape. Is that a kite? This is definitely a kite, even though it's not marked. They totally tell us right here, and you know some of us are very guilty of just like looking at pictures and not reading. So that's a kite. I like it. We figured that out. Who's the ends? Is it W and Y or is it X and Z? So because our hierarchy says that non-end angles have to be equal, are these 2 angles right here, guys, equal? Yes or no? There's a no way that those are the non-ends then. It's kind of backwards. Those have to be the ends, right? Because the non-ends, which are these guys, Bing and Bing, shouldn't those be the guys that are the same, right? So since these have to be the same, those are the ends. Cool. Please work together and find the measure of angle Z. So because this is a quadrilateral, shouldn't all 4 of the angles have to add up to be 360? And you could add these together and get 140, right? And then take 360 minus 140, and that's 220. And then why are these the same, though? Why are those the same? Non-end angles are the same, or you could use the fact that there's symmetry, however you wanted to say it, right? So you could divide it by 2, and each one of those is 110. That is correct. Either which way you guys wanted to describe it is fine. I'm going to show you how I'm going to do it, and you decide what you should probably do on test day of how to do that. Since they want me to find the measure of angle Z, I'm going to make up a variable for it. I'm just going to call it, I'm not going to use X since they're using the letter X, so I'm going to call it A. Got one question for you. If this is A, how much should this one measure right here? A as well. I'm going to add all of them up. That's 1A plus 1A is 2A, plus 80 and 60 is 140, and that should equal 360 degrees. All right? Then I will subtract the 140 over and realize that that's 220, and then I will solve for A and get A equaling 110. And you make your decision, guys, if you think showing the algebra behind that is what I would like you to show me, or if you just do it all in your head / calculator. Your choice. You know me well now in January, so whatever you think is more important. But that was good. I like the problem solving. But the math judge is coming back strong this chapter. So he likes that. Cool with that? Okay, let's keep rolling. A, B, C, D. Question, is he a kite? What do you think, yes or no? Yeah. Boom, 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 boom. Marking stuff. They say find all this junk. This is going to be a lot of homework questions. I won't lie to you. This is one of the most missed problems on our tests, and I don't understand why. It's because people don't buy into this hierarchy right away, and then they get very, very lost. So here's how I think is a great place to start. My ideal starting spot is right here. Does anybody know how those diagonals relate to each other when this is a kite? Anybody know that angle measure? That is 90 degrees because those diagonals are supposed to be perpendicular. And then what you got in this picture is, boom, you got you a green triangle, boom, you got you a pink triangle, you got you an orange triangle right here, and then you got that other white triangle that I'm not even going to highlight. It's 4 different little triangles going on. You can roll however you want to roll. I'm going to go with angle measures. I'm going to find all the angle measures that I could possibly find. So here's an obvious one. How much is this guy right now? 90. Same with this one is 90. Same as that one is 90. Cool. Use the green triangle now. Let's pick on that green triangle. Here's the 90. This one is 67. Could you find this third angle in that triangle? How much? 23 degrees. How do you feel about that? All 3 angles should add up to be 180. So here's my question. Does anybody, like if this is 67, does this have any symmetry lines either? Like does the kite have any symmetry lines? Yes, it does. What do you think? Is this guy a symmetry line right here, this pink dude? Nope, that doesn't go through the ends. How about right here? Isn't that a symmetry line? If this big dude up here is 67, how much should this one be right stinking here? 67 degrees, because of symmetry. And then if this is 23, shouldn't this little guy right here be 23? Are y'all cool with that? Okay, rock this orange triangle. See what you can find real quick. What did we get for the orange triangle? This is 39, this is 90. How much is that one? 61 degrees. Is that okay? You see how those are not the same. There's not symmetry going on. Is it 61 or should it be 51? Right, yeah, 51. Thank you. Okay. Cool, cool, cool. Oh, that's weak. And then by symmetry, shouldn't this guy be 51 degrees? And how much is this guy right here? 39. That's all the angle measures that I could find. Let's start rocking some side lengths. I'm going to go with the orange triangle first. It is a right triangle, my friends. So the Pythagorean theorem should hold. This side is 5. This side is 12. And I am missing the hypotenuse. Anybody know what that is without doing any work? That is the 3rd most popular right triangle around. That's the 5, 12, 13. So down here, see this green machine right here is 5? Guess how long this guy is right here? That's 5 by symmetry. So you got yourself another 5, 12, 13 right triangle in that case. And then check out the green boy. 4, 5, boom! Is that missing side? 3. Because 3, 4, 5 is the most popular right triangle around. 3 or not 3? That can't be 3. Why can't it be 3? Because if you had a 3, 4, 5 right triangle, who should be the hypotenuse? 5. So that's not going to work. So what we'll do is we're going to do the right thing. Now, we're not going to make up variables for things if we don't have to. We'll do the Pythagorean theorem. Let's do 4 squared plus 5 squared should equal, instead of making up a letter for that, let's call him what he really is. He is the distance from A to B squared. I can see that's just the distance from A to B. So do the Pythagorean theorem, please. So I got myself down to 41 equals the distance from A to B squared. So then what the heck does the distance from A to B equal, dear friends? Square root of 41, which is not, not a perfect square, so we're going to leave it like that. We put them in the picture, square root of 41. What do you think? Should I do that Pythagorean theorem all over again right here, or do I know how long this side's supposed to be? Dude, it's a kite, you know? It's like, come on now, square root of 41. You're cool with finding everything that you possibly can. So it is now your turn to please pause the video. Please put the letter U right here also. I didn't put that on your worksheet. So throw the letter U right there and give the video a pause and try to find everything that you possibly can. I'll get you started. Start, boom, right here where the diagonals intersect, because this is a kite. It really doesn't matter what order you go in. You just got to find all the stuff that you can. I usually roll with all the angles, so I got my 90s right away. Here's the 43. Based on symmetry, that's got to be a 43 because, dude, there he is. Some people, if you highlight the symmetry line, that really helps a lot of people, you know, so there's the symmetry line right there. And then since this is 43 and that's 90, that's got to be 47 degrees. Please don't go with what the picture looks like because it's really not looking like it's 47 degrees. We're just going to go with what the math is. And then shouldn't this one be 47 degrees? Are you okay with that? Then here's a 20-degree angle, so that's got to be 20 by symmetry, and then that means this has to be 70 degrees and 70 degrees to get them all to add up. You guys cool with all the angle measures? Then side lengths. Here's probably the most forgotten thing, to throw a 12 right there and to throw a 5 right there. It's like it's so obvious. It's like, oh yeah, duh, I forgot to even do that. And then you see this little 4 right here. It's kind of hard for some people to see. Here's the right triangle in blue. One side is 4. This side is missing, and the hypotenuse is 5. Any guesses on what that dude's supposed to be? 3. Once again, don't look at how they look. You know, it's like the 3 is way longer than the 4. Go with the math. And then since this is a 4, shouldn't that be a 4 based on symmetry? And then I got to find this dude, so I don't have a special rule for him. So 4 squared plus the distance from U to S squared should equal 12 squared. And that's 16. That's 144. Subtract that over, and that is a 128. Is that right? Check me out. Is that 128? And then you square roots. 128. And put him in the picture. So kites, man, it's all about knowing what's true about their diagonals and their symmetry lines. That's the whole purpose of. And of course, we'll get some proofs that we could do too. So first thing we'll do is we'll write all given. So we're given triangle TRI is isosceles with vertex R. Cool. So they gave us an isosceles triangle here. They also gave me triangle TAI is isosceles with vertex A. So cool, they gave me 2 different isosceles triangles. Well, we know a lot about isosceles triangles. We can either get some sides the same or we can get some angles the same. They want us to prove that this shape right here, TRIA, is a kite. So the way I ask myself this is, how can I do that? What do I need to be a kite? Do I need some sides the same or do I need some angles the same? I believe I need some sides the same. So I'm going to use this red isosceles triangle right here. Triangle TRI is isosceles with this vertex of R right here. So if R is the vertex, shouldn't this side and this side like totally be the same? And all we got to do is go write that down. So segment TR is the same as, which we call congruent, segment RI. And the reason behind that, keep your steps nice and lined up, is because they gave me an isosceles triangle, and it has nothing to do with like the base angles with that crazy theorem, so it is just the definition of isosceles triangle. That's what it means to be an isosceles triangle, is you've got at least 2 equal sides. So I've used this red guy. Ba-bing. Then they gave me a whole nother isosceles triangle right here in green. This dude right here is isosceles with vertex A. So if A is the vertex, that should mean that these 2 sides are the same. Remember, we have to mark them different, right? So segment TA is congruent to segment IA. For the same reason, it's because they gave me an isosceles triangle, so it should have at least 2 equal sides. So I did all that. There's no transitive, nothing's crossing each other out, but check it out. Look at that guy. Does he look like he's a kite right now? Does he have 2 distinct pair of consecutive sides equal? Yep, here's 1 pair. Here's a second pair right here. So I'm going to go all and say, hey man, this thing is a kite. Tria is a kite
because he's got two distinct pair of consecutive sides equal, or in other words, that's the definition of a kite. So basic when you really think about it. It's like, oh, of course. So nice. Then, of course, they say find the value of x in this polygon below. This dude right here, not a kite, right? He is just a quadrilateral. So if we go to the hierarchy, one of the properties says that the sum of all the angles should be 360 if this is convex, which he is. He doesn't dent in. So we're going to add all these bad boys up. So we'll add our x's together. Here's 5x and 3x. That's a total of 8x. And then we'll add up all our constants. So negative 8 plus 51 plus 4 plus 89. We add those all up, and that's 136. That should all add up to be 360. So if I take 360 and subtract away the 136, I get 224. So 8x comes down, and I'm left with 224. And then we divide that by 8, and I got x to be 28. So that was just a quadrilateral, right? So if he's convex, all four angles will add up to be 360. And then finally, they ask us to find the area of this shape, even though they didn't actually find us to find the area of this shape in the instructions. We've got to recognize the type. This is a kite. And then his formula is, according to the yellow card, 1/2 diagonal 1 times diagonal 2. I just got to know the two diagonals, and they give them to me, right? So 1/2 times 18 times 11. It doesn't matter which one's which. So we'll do 18 times 11, hit equals, and then divide that by 2 to deal with that 1/2, and I got 99. The area equals 99 square feet. So sorry it didn't say. Anytime they ask us to just recognize the type and give us all this information, they want us to find the area of the shape. So if it says that on any worksheets, we better get that done. Let us know if you have any questions.